Life should be much better. Easier than the first chapter, yes. Well, I'm going to do some explanations which will help you because, and I'm going to warn you of this, in my math lab, I am going to take away the show me an example and help me solve this. Because when you hit those, they go through a long algebraic explanation, when in fact, everything past step 2 was algebra. The only thing you need to know is the calculus. And I want you to learn how to recognize if you got the correct answer using the calculus without completely simplifying that answer using algebra. The algebra is not the important part. The important part is, can you do the steps in calculus? I think you'll appreciate it.
That's literally the only way I can do it. That's it. I would
Well,
not even come
if you
close
want me to turn it back on a little while, I will turn it back on.
Please do.
I will, but it's going to be turned off at least to begin with, because I think you'll see that the way that the amount of work I want you to do is a lot less than they want you to do. Okay? I don't want you to spend hours doing homework that should take 15 minutes. Who else needs their notes?
Oh, that's fine. I'm sorry.
That's all right. So I'm actually trying to help you because every time in the past that I have taught this class using Pearson, the students have complained bitterly that their explanations in my math lab for chapter 12 don't make sense. Okay? I just get lost, and it's because you get bogged down in the algebra, and I understand that. So pay attention to what I do. I will post plenty of explanations. If you have questions on problems in your homework, ask my instructor. Click that button, because I can get your problem, I can pull it up, and I can either show you how to work it in 3 steps, or I can make a 3-minute video and explain everything and send you a link to it. Okay? So what we're going to talk about now is techniques for finding derivatives. And what you saw as a long 4-step process that took a whole page in the last chapter, you're going to see that it's going to take 2 steps. If that. Sometimes 3, sometimes only 1. So the derivative is a useful tool, and in order to take full advantage of it, we need faster ways to find it without having to do 14 pages of algebra. Now, I want you to understand that throughout the course, they use all of these different notations for the derivative. Every single one of these means the derivative of some function f of x with respect to x, which with respect to x means x is the independent variable. Okay? That's all that means. So f prime of x says take the derivative of f of x. dy over dx says take the derivative of y with respect to x. d over dx of the function says take the derivative of the function with respect to x. And dx in brackets f of x says take the derivative of what's inside these brackets. That's all saying the same thing. This is the notation you will most often see me use because it's less work. The others you got to write a lot more. The other notation that you may see me use occasionally, especially as we get into chapter 14, may be the dy over dx, and there's a reason for that at that point. Okay? That's actually referred to as the differential notation. They all have names, but I like f prime. So the first thing we have is the derivative of a constant. And basically, if f of x is a constant, in other words, if it is a horizontal line, because that's what f of x equals a constant is it's a y equals some number line, it's a horizontal line, the derivative of that constant is 0. Okay? Its derivative will be 0 every time. And it makes sense that that would happen, because if you're looking at a line, y equals x, or excuse me, y equals k, then whatever k is tells you that that's the y-intercept, but it says every point on that line has that same y value, so there is no change in y. The change in y is 0. The slope of a horizontal line is 0. And what a derivative gives you, and I want you to hear this and wear it into your brain, the derivative is the slope of a function at a point in time. It's the slope of any function at any point on that function. That's what derivatives are. They are slopes, rates of change. So the derivative of a function that has 0 rate of change is going to be 0. So for example, if you have f of x equals 9, its derivative is 0. And if you have h of t equals pi, pi is not a variable, pi is a constant. So the derivative of h of t then is 0. If y is equal to 2 to the third power, 2 to the third power is a constant. 2 to the third power is 8. C is y equals 8. And the derivative of a constant, y equals 8, is 0. Yes, ma'am.
On Ernest, it doesn't like have the little part like BT brackets H. Is that like that?
No. Actually, the way that I would write every one of these by hand, let me put my paper copy back up here again. I'll tell you what I would write, because I have a paper copy of the slides, because I'm not showing you all of it on the PowerPoint. Here's my copy, because that's not going to be how I would write any of those derivatives. Well, I'd write the first one that way. I would have, if f of x is equal to 9, f prime of x is equal to 0. If I have h of t equals pi, h prime of t equals 0. If I have y equals 2 to the third power, y prime is equal to 0. Okay? That little prime sign up in the air is what tells you that it's the derivative of the function. So think of y prime, f prime, h prime, g prime. Those are all slopes of their function that they belong to. Now, you probably have a copy of this already printed out in your notes, because I didn't want you to have to write it down. What this basically says is that if you have some function that is a variable raised to a power, the way that you take the derivative of that function is you bring its power down in front and turn it into a coefficient. And then you reduce its power by 1. That's what it says. Basically, the short-term, easy way to remember for the power rule is drop and reduce. Drop that power down in front, reduce it by 1. That's how you do it. Drop and reduce. So now we're going to proceed to the paper. Although there's really not much to write, I could just show you the answer, but it helps to see what I'm going to do. So here's the power rule. F of x is equal to x raised to the 6th power. Find f prime of x. Almost. F prime of x says take the 6, drop it in front. keep the x, reduce the power by 1. Okay? The derivative of x to the 6th power is 6x to the 5th power. That's it, you're done. No 4-step method, no extra work, no algebra. That's it, you're done. Okay? And here's one for you to do. And I'm making these up as I go along. If y is t to the 3rd, what's y prime? 2t squared. No, 3t squared. Because the 3 comes down in front and then you reduce it by 1. Okay? Just like the 6 came down in front and then you reduce it by 1. If y is equal to t and that's equal to t to the 1st power, because remember t to the 1st power means that there was a 1 that was understood there, so that's not t to the nothing. Then dy dt is, or y prime is, do the steps. Where does the 1 go? So I drop it down in front of the t, right? And then the power becomes, I'm sorry, not t minus 1, 1 minus 1. Okay? But what is t to the 0 power? 0. 0? Is t to the 0 0? What is anything to the 0 power? It's 1.
What are you doing with the y?
Okay, the y is right here. This is the derivative of y with respect to t, and that's the same as saying y prime. But you got to remember, anything to the 0 power is 1. So that tells you then that 1 times t to the 0 is 1 times 1. So y prime is equal to 1.
Sorry, can you explain that one more time? I understand when it's like normal numbers and x's and stuff like that, but yeah, I don't understand. So anything to the 0 power.
Yeah,
So literally the answer is 1.
the answer is 1.
So, okay.
Okay.
So
now-
even if it was like 2 to the 0 power, would be 1?
Well, no, 2 to the 0 power is equal to 1, but then the derivative of 2 to the 0 power would be 0 because it's a constant. That's the part you missed at the very beginning. Okay, that's fine.
So if it was say dy over dt squared, would the answer then be
Mm-hmm. Yes. Well, no, it'd be 2t. It would be 2t. If I understood what you were saying, if you have y equals, let's just go with x.
Yeah, that would be good.
If we have y equals x squared, dy dx or y prime is equal to, bring the power down in front, it's 2, keep the x, reduce the power by 1, and 2 minus 1 is 1, so it's 2x, okay? No more complicated than that.
pretty much just ignore like the EY and
Yeah, yeah, it's either call it y prime or f prime of x. I'm not hung up on what you call it as long as you give me some representation of what the derivative is. You want to write out the derivative, that's fine with me. Okay? Now, to kind of push the point here a little bit, pay attention here on the calculator for just 1 second. Since I don't have any t's on the calculator, I'm going to graph y equals x. Okay? So there's the line y equals x. What's the slope of y equals x? 1. What's the derivative of y equals x? 1. The derivative and the slope are the same thing. Okay? Need to remember that. The derivative and the slope are the same thing. And it's easiest to understand with linear equations. Suppose I have y equals 3x. What's y prime? Okay, it's just 3. Because I took that 1 and I brought it down in front and said 1 times 3 is 3. X to the 1 minus 1 is x to the 0. And x to the 0 is 1, so the answer is 3. What's the slope of y equals 3x? 3. Okay? The derivative and the slope are the same thing. It's easy to do with lines. It's not as easy to do with a quadratic equation because you never thought about having to find the slope of a quadratic equation because it has lots of slopes. Its slope changes every time it changes a point. Okay? But linear ones are pretty easy. Okay, if y is equal to 1 over x to the 3rd, find the derivative. That's all that dy dx means, is the derivative. Find the derivative. So dy dx, or y prime, how am I going to apply my power rule? Because remember, this is what y looks like. Okay, but how do you know that? Okay, then let me ask you a question. Is there a way to write this with a negative power and have the same expression? It just looks different. What do negative powers do? Time for a little review of exponent rules. And if you've done your skills quiz, you should have run across one that you had to convert a negative power to trying to get you to point yourself at the derivative rules. I'm sorry, the exponent rules. Exponent rule says that the definition of an exponent tells you how many of these you have. So in case of in case of e equals 3, that becomes x times x times x, which is x cubed. That's basic exponent rule number 1. It tells you what an exponent is. It also says that if you have x squared times x cubed, that you add the exponents. Because this is 2 x's, and this is 3 of them, which gives you a total of 5 of them. And then the last basic definition was x to the negative 1 is 1 over x. X to the negative 2 is 1 over x squared. Basically, negative exponents move things to the other side of the fraction bar. So if you had x to the negative 5 over 1, that becomes 1 over x to the 5th. Okay? So what a negative exponent tells you is that you need to move the variable to the other side of the fraction bar. If it's downstairs, move it up. If it's upstairs, move it down. So basically, you're taking its reciprocal and making the exponent positive. Okay? Well, here's a situation, and I know your algebra teacher spent ages beating it into you, that you could not have negative exponents. Negative exponents are bad. I'm not your algebra teacher. Negative exponents are your friend. They help you do calculus. Okay? If you have 1 over x to the 3rd, that's exactly the same thing as seeing x to the negative 3 power. Those are identically the same thing. I can't do power rule on this because that's a rational expression. It's not a power. This isn't a rational expression. This is a power function. So dy dx, or y prime, you take that negative 3 and put it in front, then you take that negative 3 and reduce it by 1. This is the part you're going to get tripped up if you're not careful. Because when you subtract 1 from negative 3, you get negative 4. So you bring the power down in front and you reduce it by 1. But if it doesn't look like a power, make it look like 1. Okay? If it doesn't look like a power, make it look like 1. Do we need to get some lights off so you can see better? Does that help? Okay, one more question, just to make sure you understand, because I've got basic examples, but then when I see a little bit of puzzlement still going on, I'm going to give you one like it. What if I have y equals 2 over x to the 4th? How can I write that with negative exponents?
2x
To the negative
4 power.
4th power. Okay? Then here's how I find y prime. I take the negative 4 and drop it. I'll leave the 2 alone, I'll leave the x alone, but then I reduce the power by 1. So y prime is equal to negative 4 times 2 is negative 8, x to the negative 5. Now, if you were in my math lab would make you go another step. They would say, no, 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 no. Well, my math lab doesn't, their explanation does. No, 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 this is negative 8 over x to the 5th power. And at that point, when I was sitting where you are, I'd be looking at it going, how did you get that? Well, all they really did was they moved this back down to the bottom. It didn't change anything. But looking at that, it's not clear to me how I used a power rule to get from having this to having that. How did they do that? Okay? But if you change it to a negative power, it makes it easy to figure out. And I'm not expecting that last step from you. I'm expecting you to stop right there.
What I'm a little lost is like, the y, what is that y to the 1st power equals, where do you get
4 is because I had 2 over x to the 4th. That was the original function. That was y equals 2 over x to the 4th. And I changed it to say that's 2x to the negative 4 power, so that I could get it up out of the denominator and not have a fraction. And then I just applied my power rule. And the power rule says bring the power down in front, keep whatever's on that line, whatever you have left, and then reduce the power by 1. So I subtracted 1 from it. Okay? Is anybody else still confused? Because this is not supposed to be confusing. This is supposed to be fairly straightforward. Okay, let's try some more examples. Actually, I think for a minute I'm just going to pop that up to full size so you can have more space. We don't need the calculator right now. Okay, this says find the derivative of 4x, or x raised to the 4/3 power. So here's your function. This says find its derivative. Apply the power rule. What does the power rule say to do with the 4/3? Bring it to the front. What do I do with the x? Keep it. What do I do with the 4/3 power? I have to subtract 1 from it. Now, if you don't want to subtract fractions, that's strange because it looks really blurry up here on my computer screen, but it doesn't over there. If you don't want to do the subtraction with the fractions, you pop your calculator up, because you all know how to do this. Take 4/3, subtract 1, and have it give it back to you as a fraction. So that's 1/3. Okay? Questions? Now this is another one where if you're in my math lab and you ask it, show me an example, it's liable to take you down some long yellow brick road into algebra and come up with something that doesn't look anything like that, and yet it's the same thing. But if you type in an equivalent expression, my math lab will take it. It will take it. Okay? You don't have to do all that extra algebra. I want to see the first step. Okay. Anybody see any powers here? What's a radical? What's the difference in x squared and square root of x? Are they related? Now it's like the inverse of the reverse. You have x squared and square root of x. So if I have a square root of z, what power would that be? To the half power. Square roots are 1/2. Your radicals are fractional powers. So we snuck a fraction power in on you on the last one. They could have written that as a radical, but they didn't. This one is a radical. Anything to the 1/2 power . is the same as the square root. If this had been the cube root of w, that would have been w to the 1/3, okay? So if you got a root, turn it into a power, because you got a power rule. The power rule is easy. So then if I'm going to find dy dz, which is y prime, first I need to take this version of it, and if y is z to the 1/2 power, what do I do to find the derivative? That's the second step. These steps have to go in order. What's the first step?
The 1/2 in front of it.
Pull the 1/2 down in front. Drop and reduce. What's 1/2 minus 1? Negative 1/2. Would your algebra teacher like that answer? Nope. Do I care? Nope. Same thing. If I plug in a number for z and I multiply it by 1/2 after I've raised it to the negative 1/2 power, I get exactly the same answer. Whether the power is positive or negative, if I put that z down here and make it positive 1/2, it doesn't make any difference. Calculator's going to give you the same answer. Don't work more than you have to. Power rules, two-step process. Drop, reduce. Now, I've actually kind of already done this. I kind of snuck it in on you when I snuck in those extra examples. Basically, what this says is if you've got a constant times a function, go ahead and take the derivative of the function and then just bring the constant back down and multiply with it. Just let the constant ride along. It's just a hitchhiker. Okay? So in order to see how this works best, you have y equals 8 times x to the 4th. What that rule was telling you is that you have y is equal to 8 times some function which is x raised to the 4th power. The down and dirty of it is if you're going to take y prime, drop the exponent, 4, keep the rest there, except you reduce the power by 1. 4 times 8 is 32, x to the 3rd. Power rule always works the same. Okay? Y equals negative 3/4 times x to the 12th power. Y prime equals what comes down in front. Okay? Everything else stays the same, right? And then I have 12 minus 1 for my power, my new power. Now, 12 times negative 3/4. Somebody's way ahead of me. But if you're not sure that's, you know, what that is, that's 12 times, in parentheses, negative 3 divided by 4, close parentheses, math, fraction, negative 9. And that's x to the 11th power. Okay? dy dx and y prime are the same thing. It just means take the derivative of that function. Here's the function. What's the derivative of negative 8t? What's the actual power there? Just 1. So 1 times negative 8 t to the 1 minus 1. That's 1 times negative 8. T to the 1 minus 1 is t to the 0, which is 1. And multiplying negative 8 by 1, doesn't matter how many negative 1s you multiply it by, it's still negative 8. What would the graph of negative 8t look like? It's a straight line going down fast. Its slope is negative 8. Its derivative is negative 8. Okay? I want you to keep derivative and slope connected up in your mind, because that's going to be important. My function, 10p to the 3/2 power. If I'm going to find the derivative, what do I do first? Down in front? Okay. And then I keep what? And then I need to subtract 3/2 minus 1. What's that going to come out to be? Well, 3/2 minus 1 is 0.5, but that's a half. Now the only thing left to do is say 3/2 times 10. There's nothing actually wrong with that, except that when you get ready to type it into your calculator, since you've got two numbers together, you probably want to go ahead and multiply those two numbers out so that you have less to type in. So 3/2 times 10 is 15. Okay? That's just a new way of writing the derivative. Don't get hung up in the notation. You're still doing the power rule. And if you have trouble multiplying 3/2 times 10, get your calculator. I will tell you this, if this starts out in a fraction, like this does, then your derivative ends in a fraction. If it starts and you've got a decimal up here and you want to give decimal answers, that's good. But if it's a fraction starting out, keep a fraction at the end. Help me fix this. I can't do power rule. How do I fix it so I can? Exactly. Now I do power rule. What's y prime? Okay. Times which then is negative 1 minus 1 is negative 2. And negative 1 times 6 is negative 6. That's as far as you need to go. Okay? Feel like you got the power rule down pretty good? Okay, we're gonna add a step. This looks confusing. I'm going to put this in English. If you have a function that is either the sum of two other functions or the difference of two other functions, take the derivative of each one of those terms. Each one of those terms is actually a function of itself. Take the derivative of each term and then keep the operation that went between them. Easiest way to understand it is to do one. This is one of the terms, this is the other term, and they've been added together. The derivative of the first term is what? 18x squared. Does everybody see that? 3 times 6 is 18. X to the second power. 3 minus 1 is 2. Okay? We have 15x squared. What's its derivative? Okay. 2 times 15 is 30. X to the 2 minus 1 is 1. The original problem said add those two together. Done. That's it, you're done. Don't have to do anything else. Okay? Help me rewrite this. Okay, that's the first part. How in the world am I going to get the derivative of 6 times the square root of t? And remembering that that's equivalent to 6t to the 1/2. Don't get too excited about doing all these in your head because it will trip you up sometimes. If it's 6t to the 1/2, then the derivative is 1/2 times 6t to the negative 1/2, because 1/2 minus 1 is negative 1/2. So that makes it 3t to the negative 1/2. Okay? And we got another term. How am I going to find the derivative of 5 over t? Okay, 5t to the negative 1, which then makes the derivative negative 5t to the negative 2, because negative 1 minus 1 is negative 2. Now, you don't have to do this, but most people don't like seeing a plus and a negative together. So go ahead and change your sign, fix your signs. I don't mind if you do a little bit of algebra, just don't do complicated algebra without a good reason. it's minus, not plus. Okay? Is this better than chapter 11? I promised you it would be. Okay, let's do another one. You need to get plenty of practice, make sure you can do this. Oh man, they got really ugly here. What are we gonna do with that? Okay, close, but not quite. You are on the right track. You're on a very good track. We just gotta be careful and do this, not miss anything. Well, you can't factor the numerator because unfortunately, that's a square root. So, we could try to translate it to a power, but that means we'd be factoring out a square root or a 1/2 power. That would get pretty ugly. So, no, I don't want to do that. So the first thing I'm going to do is I'm going to break it up, because remember this is the derivative of a sum. So I'm going to break it up and call this x cubed over x plus 3x to the 1/2 power over x. And now a little bit of algebra goes a long way. X cubed over x is what? Okay, so far so good. And you said that before. What is x to the 1/2 over x to the 1? What do you do when you have a quotient? That's x to the first power. Little review lesson. Let's come over here for the people. Yes, 1/2 minus 1. For the people that are trying to remember, x to the 5th over x squared becomes what? Okay, and where did the cube come from? 5 minus 3. So top minus bottom, right? On the powers, top power minus bottom power? Okay. Then 3x to the 1/2 over x to the 1 is going to come out to be 3x to the negative 1/2, because 1/2 minus 1 is negative 1/2. Okay? So now we go piece by piece. The derivative of x squared, what is it? Okay. Are we done with that one? Okay. What's the derivative of this part? Okay. Which is negative. Or 3/2. Now this one you might want to clean up a little bit. Negative 1/2 times 3 is just negative 3/2 times x to the negative 3/2. And we'll just drop that 2x right on down because it didn't need to be cleaned up. It looked pretty good as it was. So f prime of x coming from over here is equal to 2x plus negative 3/2 x to the negative 3/2, or, and you don't have to do this, but once again, a lot of people don't like seeing two signs together, 2x minus 3/2 x to the negative 3/2, and you're done. Okay? Questions? Anybody feeling like you can't do this? If you need help, I'm gonna send out an email or a messaging reminder, and I want you to text me back, or I may put up a folder in Shobi and ask you the same thing. Since I know people are struggling and there's not as much tutor access as I wish there was, and it's not always a great one, I'm gonna send out a message and ask you to tell me what hours you would be able to come on what days to have a little calculus party in the workroom at the end of my hall. I'm always free the hour after class. So I'll be more than happy to meet with everybody for an hour after class and help you get started on your homework or clear up anything that you still had questions about in class. Or simply to hang out there and let you do your homework while I'm still there and can help you. But I also have the hour before class. As long as you don't mind me eating, you can come and sit with me and have lunch and we'll do calculus, if you can stomach doing calculus while you're eating lunch. Or I have hours on Friday that are very flexible. I would just need you to tell me what kind of hours could you come on Friday. If you wanted to spend a couple of hours Friday morning, a couple of hours Friday afternoon, just let me know. Because I know tutoring is limited on calculus and I want to try to help out. But hopefully chapter 12 makes you feel a little bit better about this. Oh my. I have a power rule, all right, but unfortunately it's on a function. And I can't just take derivatives because this is all mixed up. How can I rewrite f of x? Help me rewrite f of x so that I can use my power rule.
Would you go ahead and multiply the other?
Yeah, I'd go ahead and multiply it out. If you've taken your skills check quiz, you remember that there was one of these on the skills check quiz to remind you needed to know how to do that. So 4x squared times 4x squared is 16x to the fourth. And then minus 3x times 4x squared is negative 12x to the third. And 4x squared times negative 3x is again negative 12x to the third. And negative times negative is positive 9x squared. And then, since I don't want to have to do two derivatives, if I can do just one, combine your like terms in the middle. And now you know why you spent all that time learning to square binomials. This is where you needed it. So there's the equivalent to f of x. Now you tell me the derivative. Okay. Excellent. So was the calculus hard? What was the problem with being able to do the calculus? Algebra. Okay? You do have to do some algebra. I'm just not going to make you do all the algebra that my math lab does. Now, here's another thing that you probably don't know, but you can actually use your calculator to verify that your answer that you got by doing your calculus for your derivative was right. There's no reason to miss one. If you've got one you're not sure is the same as that ugly answer they put in the My Math Lab answer, or you're not sure that your answer is really the right answer because there was a lot of algebra before you got to that part, then here's what you can do. Suppose we have the function f of x is equal to 6x to the third plus 15x squared. Is this the right derivative? Is it? Yeah, because 3 times 6 is 18, and the cube becomes a square. 2 times 15 is 30x, and the square becomes first power. Here's what I want you to do. You should go to your calculator. Go to your y equals menu. And I want you to enter in first the function f of x. So enter in 6x, and you can either do to the third power or you can choose the cube off of the calculator, plus 15x squared. But don't hit enter just yet. Back up and put your cursor on the equal sign and hit enter. I want you to put the function in, but I don't want to graph the function. I'm not interested in the graph of the function. But I need it there to do the next step. So put it in there, but turn it off. All right? Now, type in the formula that you got for the derivative, which was 18x squared plus 30x. Don't turn that one off, leave it on. Now you can hit enter, and we're going to enter one more. And you're going to want to follow the steps here on y3. So I'll give you a little catch-up time. y1 equals f of x. y2 equals f prime of x, whatever you figured out that it was. When you get, now this one's off, this one's on. It has to be there, but it is turned off so I don't see the graph. This one's going to be on also. This is y3. When I get to y3, press your math button. Scroll down to number 8. And get in deriv. That's the numerical derivative. When you hit enter, it'll paste it in at y3. Okay, I may need to come and look at yours. Yours may, it'll be the same thing, but it's shuffled around on your screen. Oh, okay. Yours should be the same as mine. Okay, you're still on your equal sign. Or off your equal sign. Oh, if you get too far, that turned off. Okay? Now, this is what you have to type in, yes. Okay, yeah, some of y'all's are newer, so. Okay, yeah, it's giving you the notation that you saw on that first slide. So, in deriv, let me see this for a second, make sure that I tell everybody the notation right correct. If you got the 84, it brings up d over d box. Type an x in that box. And then in the parentheses, you got another box. We're going to put in y1, just sit tight. And then in the last box, I think you're going to put an try to bring in my TI-84 calculator from here on out, so I can do it both ways for you. Okay, so your equation, you're gonna take the derivative. Now on the 83, the order of this is different. On the 84, the x comes first, then the function, and then another x. On the 83, the function comes first, and then the x and another x. So it's in deriv, and your function is in y1. To get y1 in there, that's the steps you're going to take. You're going to hit the bars key, go over to y bars, and hit function. Well,
It's the same for the 84.
yes. So what you're trying to do is get in there where your function is. I want you to be able to put in y1. Now, you could actually retype the function in there if you wanted to, but some of the functions, I'm just warning you now, some of the functions that we're going to take derivatives of can get really ugly. And when they get really ugly, you don't want to type it any more often than you have to. So putting it in y1 lets you continue to use it. So put y1, and then here's the x that the TI-84 people had to put in first. Now type another x at the end. And close your parentheses. Now the language for what I just told you to do is y3 is saying get the derivative of the function that's in y1, take it with respect to x, and graph me all of the x values. And then what y2 is saying is this is the derivative at every value of x. Now the way we're going to see, and there's two different ways to check this, the way we're going to see that these are indeed the same functions is we're going to hit the zoom key and go down to number 10, which is zoom fit. And when you do that, all you have to do is either put your cursor on zoom fit or press a 0. And it's going to take it a minute. It's thinking. What it's doing is it's going and looking at all the stuff on the y equals menu and it's calculating so that it knows how big it needs to make the window so it can show you the graph. And it'll find the graph every time. You see, it's still thinking. It's still graphing. But you're not seeing anything happen. How many equations are on the y equals menu that should be graphed? There's two, right? I only see one line. What does that mean? It means that their graph is the same, therefore the expressions in y1 and y2 are the same. Okay? You can figure this out by tracing. You see my cursor there? It may be that your calculator initially had different x ranges to start out.
What should we set?
You might want to start with zoom 6 and then do zoom 0. It takes a minute because it has a lot of calculations. Okay? So you should be technologically sophisticated enough by now to realize I'm sitting here on y2 and it gives me that xy pair. But if I move to the other equation, to y3, that's the same xy pair. There's no difference. And if I even go look at the table, notice that the y values, I can scroll up and down in that table all day long, but y1 and y2 have the same numerical value. That means those two expressions in y2 and y1 are equivalent to each other. So did you actually get the right derivative? Yeah. Okay? So that's a useful thing to know. We got about 5 minutes left, but I don't think we have 5 minutes worth of work left to do, so. Okay, now we're to an application problem. This may be the only part of it we get done. If it is, that's fine. I'll finish the recording and post it all up in Shobi. Suppose the total cost in hundreds of dollars to produce X thousand barrels of a beverage is given by C of X is equal to 4X squared plus 100X plus 500. Find the marginal cost. How would I go about finding the marginal cost? Well, take the derivative, because that word marginal says you're looking for a derivative. So I need C prime. I know I'm going to put in X equals 5, but I'm going to do that at the end. I need C prime. Tell me what is C prime of X. 8X plus 100. And if C prime of X is 8X plus 100, what is C prime of 5? It's 140. Now here's the part that y'all have issues with, so pay attention to this, because people are probably lost. I haven't graded your test yet, but I know some people lost points because they didn't do this. C prime of X is 140. The marginal cost for 5,000 barrels times 5 is 40 plus 100. Okay? Is X is 140. $100. So that's $14,000 per barrel. Okay? Yes. This is 2 times 4 is 8x to the first. 1 times 100 is 100x to the 0. And the derivative of a constant is, okay? So when you plug it in, you get C prime is 140, and 140 hundred is $14,000.